Hello, AP Chemistry students. Okay, so I told you I'd make this short video if you felt like you needed a little more help with doing these limiting reactant and solution problems. So this is number 9 on page 20. And first thing you got to do is, of course, write out a balanced equation. So it says you have 2.12 grams of strontium nitrate reacting with the solution of sodium sulfide. So I wrote it out. It's a classic double replacement, and I balanced it. Okay, so of course, the strontium is hooking up with the sulfur, and that is a precipitate. Most sulfides are insoluble, of course, unless bonded to alkali metals, ammonium ion. Okay, so that's my precipitate. And then sodium and nitrate, those are my spectators. Okay, just sort of swimming around. Okay, so anytime I give you grams of one reactant, information about the other reactant, got to figure out which one's your LR. It's not quite evident by looking at these numbers, so we're going to have to stoic this out. So I'm going to take my 2.12 grams of the strontium nitrate. And I'm just going to convert that puppy to moles. Okay, so I already looked up the molar mass. Or maybe I just have them all memorized. Maybe. Okay, hopefully that's right. And that guy works out to about 0.0100 with sig figs moles of strontium nitrate. All right, same idea for the sodium sulfide, but it's a solution. So I'm just going to take the volume, which I converted to liters, and multiply it by the molarity. Okay, so liters cancel out, and we're left with about 0.0446 moles of sodium sulfide. Okay, so I look at these numbers and I say, well, they're reacting in a 1-to-1 ratio. Pretty easy. Which one am I going to run out of? So smaller number wins. So my LR is the strontium nitrate. Okay, great. So that's like phase 1. Now that you got that figured out, you pretty much just got to calculate every mass and every ion concentration that would exist in this solution after the reaction takes place. So I always start with the easiest thing to figure out, which is how much precipitate would be sitting at the bottom anyway. So I'm going to figure out grams of sodium sulfide. Totally the exact thing, sort of thing you did last year. So I'm going to start with my, so let's see, grams of strontium sulfide. I'm going to start with my LR. I'm going to say, okay, if I react all this strontium nitrate, how much precipitate can I make? For every 1 mole strontium nitrate, we will make 1 mole strontium sulfide. All right, so that's pretty, oop, I'm not done. What's going on here? Let's erase that. Oh, geez. We got things going on here. Okay, let's keep going and convert that to grams, of course. So 1 mole strontium sulfide, and I calculated the molar mass of that as well. It's about 119.68 grams. Calculate that through. That's how I get the 1.20 grams of strontium sulfide. Bam! Okay, that part's done. Okay, now all the ions in solution. Well, let's see here. Sorry, I'm coughing in your ear. Still coughing in your ear. So 1 ion concentration is always 0. So I take a look, and I know that strontium nitrate is my limiting reactant. So where did 100% of these strontium ions go? Okay, well, bing, 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 bing. They're locked in this precipitate. Okay, then. So what's the strontium 2 plus ion concentration going to be in solution? It's going to be absolutely 0 molar. All strontium ions are locked in precipitate. Now, does that make sense to you? Okay, that if that's the limiting reactant, every single one of those strontium ions are locked in that precipitate. Okay, well, that's fine. So that's strontium story. Well, what about the other part of the precipitate? That would be the sulfide ions. Well, let's see. So that's not the limiting reactant, but some of the sulfur is locked in this precipitate, but some of it's going to be left over. So the leftover guy is always the hardest ion concentration to figure out. So let's see. But it's the same steps over and over again. Okay? So 1, you got to figure out how much sulfur is actually in that precipitate. 2, you got to figure out how much sulfur was available from the start. 3, subtract those numbers. 4, get yourself the new molarity. All right, so if I want to figure out how much sulfur is in the precipitate, I'm going to start with the limiting reactant. So I'm going to take that 0.0100 moles of strontium nitrate again, Okay, and I'm going to say, well, let's see, if I know I'm going to use up all this limiting reactant, for every 1 mole strontium nitrate, I'm going to need 1 mole of sodium sulfide. And more importantly, for every 1 mole sodium sulfide, I'm going to need 1 mole of sulfide ions. So that right there is the money step. Because we don't really care about sodium sulfide, we care about those sulfide ions. How many of those sulfide ions are locked in the precipitate? So my dimensional analysis does exactly what it's supposed to. I would need 0.001 moles of sulfide ions to react with the 0.0100 moles of strontium ions. Okay, so that's how many moles of strontium ions would be needed for the precipitate. And please, I'm telling you, the more you label your numbers so that you can follow what you're doing, this is all just going to be sort of common sense and make sense. Got to stay organized. All right, so step 2 was, well, what's the available sulfur ions anyway? Well, where'd the sulfur ions come from? Okay, well, be careful. They actually came from the sodium sulfide that you had originally, okay? So sometimes the problem students have is just so many numbers, they just sort of mix up, you know, which ones they should be starting with. You just got it. That's why your work has to be super neat and clear, okay? So that was the moles of sodium sulfide from the beginning. But again, I don't care about sodium sulfide. I care about moles of sulfide, okay? Now I know this seems like kind of a lame step, right? That's because in this problem, there's a lot of 1-to-1 ratios. But man alive, you know, when you get one with a lot of, 2-to-3 and 1-to-2 ratios, this step right here is going to be a huge game changer for you. Okay, so what do we label this? This is moles of sulfide ions available, okay, from the get-go. Okay, and then step 3, well, let's see. I got sulfur available. I got sulfur in the precipitate. Subtract those two. Okay. Okay. Now, FYI, this little device I'm using is starting to write really slow. I apologize for that. Okay. And I wish both these were labeled appropriately. Okay. So I subtract those, and it comes out to 0.0336 moles sulfur. That's a 2- charge. Are you kidding me? Come on. That's left. And why is this happening? Solution. I'm so sorry. Okay, so that's step 3. And then step 4, very slowly, evidently, can you solve for the final sulfide concentration? Okay, so I'm going to take this mole value that I calculated here and divide it by the total volume. Now, in this problem, we didn't have 2 volumes adding. Okay, in fact, we just had the 1 volume and then we added solid to it. So there is no additive volume, so I'm just going to use the 0.175 liters. Okay, and then we divide that through, and by golly, that's how you get your answer of 0.198. Okay, I mean, folks, if you could do that part, you can do anything. Okay, so far we figured out the strontium 2+ is a limiting reactant. It's all locked in the precipitate. The sulfur 2-, the other part of the precipitate, some of it's locked in the precipitate, subtracted from what was available, that gave you what was left over. Divide that by the total volume, done. So the last part of this problem, this is by far the easiest part, is we have these spectators. Okay, so how do we handle that? So hopefully I'm going to switch to the new page here. Last time I did this didn't work. Come on, you can do it. Yes. Okay. So hopefully you're still looking at the reaction. So how do we figure out those spectators? All right, so I'm just going to take nitrate first and say to myself, well, where did the nitrate come from anyway? Okay, now I know it was a limiting reactant. Doesn't really matter. The source of the nitrate was the 0.0100 moles of strontium nitrate that you calculated originally. Okay, but the catch here is that for every 1 mole strontium nitrate, there's actually 2 moles of nitrate ions. That's the important part. So that becomes 0.0200 moles nitrate. Now, that's the only thing that matters. So to get the molarity, you just got to take that guy